Hello, today we will be talking about how to do hypothesis testing for proportion, and it shouldn't say proportions, it should be one proportion, on Minitab, because we're just doing one. We should be careful. Um, so if you have not done so, please download the Word document and Minitab file associated with today's example for Chapter 10. I've described it right here in case you can't find it. It is on our Blackboard site under case study number 1. So the first thing I'm going to do, if you have not read through this question so you understand what we're talking about, please do so now by pausing the video, reading carefully, preparing yourselves so that you can follow along. Okay, we're good to go. Code the class variable so that the sophomore is represented as yes and all other represented as no. So we're going to code just like we did in the last video. So we're going to go up to data, choose code, and then to text. Now that I've got my code menu open, I'm going to change my class so that my sophomores are yeses and everybody else is no. So if these don't show up right away, your variables, make sure you click into the white box so that they pop open so that you can select them. You can either select them by double clicking or highlighting and hit the select button. We're going to go over to method, and I want to do individual values. So notice it brings up like the current values that I've got, freshman, junior, senior, sophomore. It does this alphabetically. And then I've got my coded values. So I want to change everybody else except the sophomores to a no. And big key here, you want all your no's to look the same and all your yeses to look the same, because if they look at all different, Minitab will treat them as a different coded value, and then you won't have a defined success and failure, or you'll have success, failure, and something else, and you can't do a proportion test on that. Okay, and as always, I'm putting this at the end of the worksheet and asking it to summarize, because then I'll be able to double check that my no's don't look different and that everybody is accounted for. Let's go ahead and hit OK. That looks like about 5,000. I mean, it's roughly 4,000 here and then another 10,000 there, so we're close to what we want. All my no's look the same, my yes looks different, so we're good to go. There's my coded class at the end. All right, first step, check them through, that's done. Now I want to state my null and alternative hypotheses. So I want my ho and my ha. I really should stop calling them that. I find it funny though, so I can't seem to help myself. Okay, and really what we're trying to figure out here is, do I have more sophomores than the rest of the class members? So I'm hoping you look at this and they're like, well, what are the class options? There are 4 of them. We want to see if their groups are equally represented, which means if it was equally represented amongst your 4 choices, then it would be 1 out of the 4, which would mean my proportion of sophomores is a quarter. 1 out of 4. Makes sense? Now, my alternative, I suspect that there are actually more. They're more representative. There are more students in the sophomore class than there are previously. So I suspect my alternative is going to be that I have more than a quarter sophomores. So there's my null and alternative hypothesis. Please be careful, because if your hypotheses are incorrect, you proceed through the test differently, and therefore you would get a different p-value and you'd be incorrect, and that's not good. We don't want to do that. Okay. We're going to perform a hypothesis test. What's interesting about this is, in order to perform a hypothesis test, you do the exact same steps as you would do a confidence interval for the beginning part, and then you just make some different options and you get a hypothesis test. How does it look? Well, we go up to stat, basic statistics, down to 1 proportion, and not pops our stuff. I want to make sure that I'm sampling from my coded class. So I'm going to click into the white variables box, place my coded class in there, and here's where things get different. I'm going to check the box that says perform a hypothesis test because I'm doing a hypothesis test. Super easy, right? And it's going to ask, hey, what's my hypothesized proportion? Well, I think it's actually 0.25, so I want to put in 0.25. Be careful. We want to use proportions, not percentages, because this is, again, talking about proportions. All right, now that I've got this set up, I'm going to hit my options, because you should always check your options. Okay, since we checked the hypothesis button, it doesn't matter so much about what you have set as a confidence level. That doesn't matter. What does matter is the bottom 2 menus. So alternative hypothesis, this says not equal to, but I have a greater than. Oh my gosh. Okay, so I need to change this to a greater than, which is why you should always do your null and alternative first before you approach Minitab. Okay, last but not leastly, we want to make sure that we change this to normal approximation mode. If you're ever get all confused about who's who, you remember proportion, that's representing your P here. And hypothesized proportion, well, you put that in earlier. That value of 0.25. So this looks like my p is bigger than 0.25, which matches my alternative. Okay, let's go ahead and hit OK. And it produces my output for you. I want to grab this and paste it. Ugh. Why is it always trying to enumerate this? There we go. I want the original, so I can write all over it. I'm going to make my Word document just slightly bigger here so I can draw on this. Okay, so this produces a lot of output. There are some things in here that you need to be aware of. So follow along, please. The first thing I always check is right here to make sure that I've done the appropriate null and alternative hypothesis. I want to make sure that what the test I performed was matching what I supposed I was going to have up above. So I always check what I was testing against to make sure that I did the right test in Minitab. It's a good indicator whether or not you've done this correctly immediately. Okay. Next up, let's label some things. There's our sample size. Here's your sample p, so there's p hat should you need him. Ignore this for now. It's not something you really need. It's part of the whole confidence interval thing, but it's a one-tailed confidence interval, which we're not doing. The next thing you might need is you might need this z-value. This is the test statistic. This is what you would get if you did p hat minus p0 divided by the standard deviation of p hat, or standard error, depending on what you're up to. We've seen him before. That's just that z-score, which Minitab likes to call the z-value. Lastly, you have the p-value, which is the p-value. That's the dumbest thing I've said in a while. It's the p-value, you know? The probability that you got that sample or something worse, assuming that the null hypothesis was true. So, the first thing you should notice is I want to compare my p-value to my level of significance. So I look here and I notice my p-value is 0.01 or 1% versus 5%. So that tells me that my p-value is smaller than alpha. So we are going to reject. Woohoo! We want to reject. So if you're wondering why I'm excited, it's because that's what we want to have happen. So what does this tell us? The evidence suggests that the proportion, of sophomores, very least you guys to be able to spell sophomore by the end of this, is more than 25%. Now, you could state this a little bit differently. You could say that, you know, the evidence suggests that there are more sophomores, I like this a little bit better, in the sample than the other classes, because it more directly answers the question. With a p-value of 1%. Super small, so it's nice to report that because it's like, oh, yeah, it's pretty significantly different. It probably shouldn't have happened. Okay, so the last thing I'm going to do with you today is I'm going to do a confidence interval. And the reason I want to do this is because it's often difficult to go back and forth between these two types of testing, doing a confidence interval and doing a hypothesis test. And I want you to be able to do the two pretty fluidly because they are using the same menu. So the one thing to keep in mind when you're doing a confidence interval versus doing a hypothesis test is you got to make sure that you uncheck the hypothesis test box. And then the second thing you have to do is make sure that you have your alternative hypothesis set to not equal to, because if you don't, this doesn't work. So let's do our 99% confidence interval. So we're going to go up to Stat, Basic Statistics, down to one proportion, because remember, these two are in the same menu, but I don't want to do a hypothesis test, so I'm going to uncheck that button. Bam. Then I'm going to hit my options. I'm going to change this to 99%. And then it's still under normal approximation because I just did a hypothesis test, and I want to change the alternative to a not equal to. If you don't do this, you won't get the entire confidence interval. You'll just get part of it, like that lower bit I showed you earlier, that guy. I don't want that. I want the whole thing. Let's go ahead and hit OK. And there's my actual confidence interval for 99%. There she is. Or he, or I don't know why I gendered that. It's fine. So a couple reminders. If you're doing a hypothesis test, make sure your alternative hypothesis is set correct, and that you have the hypothesis test button checked. That's how you do the hypothesis test. If you need to do the confidence interval, you need to uncheck that box and make sure your alternative is set to not equal to, because that's the only way to get a confidence interval off it. Ta-ta for now.